Hey math people, it's Dr. Simmons here and I am back with another video. There is a glare in my glasses, but I need to keep my glasses on or I can't see you. But today we are talking about something that is very important when it comes to the algebra world, and I feel like in the math world. And yeah, I do feel like it's important in the math world in general, and that is solving equations. So in this video, I'm going to talk about solving linear equations, and then I'll do a part 2 where I talk about solving quadratic equations. But right now, let's focus on linear equations. So for this video, I want to, you see my exercise ball back there. But for this video, I want to focus on the steps that I would suggest you take in trying to solve a linear equation. I think I have 5 steps. So the first step is to clear the equation of parentheses. That will be your first step. Clear the equation of parentheses. Your second step will be to clear the equation of your fractions. So get rid of all your fractions. And I'm going to talk about how to do each one of these steps. I just want to put the steps out here for right now. So get rid of the parentheses, get rid of the fractions. Step 3 will be to combine any like terms that you have on each side of the equal sign. So any like terms, gather them together. Gather them together. Variable terms and constant terms. Step 4. Isolate your variable term. If you have no idea what that means, stick with me. You'll learn in just a few minutes. So isolate your variable term. Get your variable term on one side by itself. And then step 5, isolate your variable. Get your variable on one side by itself. After you've done those 5 steps, you should have the answer to the equation. So let's go through each step one by one. So before we even get started, let's make sure that we know the difference between a linear equation and a quadratic equation. So we're talking about, in this video, linear equations. Next video, I'll talk about quadratic. But linear equations, if you look down at these examples at the bottom of this worksheet, notice how all these equations have just an x. You don't see any x squared or anything like that. You just see x raised to 1 power. So because those all have an x in it, it's considered to be linear. Versus if you look at these equations, if you take a look at these, you not only see x, but you also see x squared. The x squared and the x to the 4th, all of that stuff makes it quadratic. And you have to do something different when you're solving it. We're just going to focus on linear. Just x raised to the 1st power. So we're going to go through the steps again, but I'm not going to go through it here. I'm going to go to a blank page and just write an example down, and we'll go through the steps so you understand each one. So here is an example that was from the worksheet. And the very first thing you want to do is clear the equation of parentheses. So clear out the parentheses. When I say get rid of the parentheses, really what you're doing is a distributive property. So you see this -3, you're going to distribute here and here. The 2, distribute here and here. You're distributing. When you distribute that number, it'll get rid of the parentheses. So over here, I'm going to put in burgundy to distribute. So also remember, I got an extra line there. Let me delete that. I don't know why I did that. But also remember, when you distribute, you got to distribute the sign also. So you're not just distributing a 3, you're distributing a -3, right? So this is going to turn into 1 minus 6x, and then -3 times 9, that's -27, equals 2 minus 4x. So I have cleared the parentheses. I have no more parentheses in this problem. The next step is to clear the equation of fractions. Now, this particular problem does not have fractions in it, but if I did have fractions, at this step, I would clear the equation of fractions. And I would do that by multiplying by the LCD. Now I'll just write this step down. Like I said, we don't have fractions, so we don't have to worry about that step for this particular problem. So step 3, what you want to do now is combine any like terms. Now, when you are combining like terms, I mean combine like terms on each side of the equal sign. Don't jump over the equal sign yet. You just combine like terms on each side. So if you look on the left-hand side, you got a 1 and you got minus 27. Combine those together. Don't jump across the equal sign. Just combine everything on each side. So you got negative 6x minus 26 and 2 minus 4x. So you have no more like terms on each side. And remember, we're not jumping across the equal sign. You're just combining like terms on each side. Okay? Now step 4. Step 4 is to isolate your variable term. Now, what variable term means is each one of the terms that have a variable in them, you want to get them together and on one side by themselves. So up here, you have negative 6x and you have negative 4x. Those are called variable terms. You have to find a way to get those two together on one side by themselves. And anything that doesn't have a variable needs to go on the other side. So in order to do that, I'm going to move the 6x to the other side. When you're jumping across the equal sign, you got to do the opposite of what is displayed. So since I had negative 6, I had to add 6 to both sides. And now I have minus 26 equals 2 plus 2x. I'm going to move the 2 to the other side because, again, I'm trying to isolate the variable term. I want the 2x to be on one side by itself. So now you see I have 2x by itself. And on the other side, I got negative 28. Now, when you are trying to isolate the variable term, you're adding and subtracting. You're adding and subtracting when you're trying to isolate the variable term. Don't do any dividing, multiplying, none of that. You're adding and subtracting. Now, step 5 is to isolate the variable. Some of you probably already recognize that this will be your next step. I need the variable to be by itself. The variable is x. Now, when you are isolating the variable, this is where the division comes into the place. So you divide both sides by 2, and you end up getting negative 14 is equal to x. That's your answer. So you need to isolate the variable. To isolate the variable, this is where the division comes into play. So you have to divide to do that. All right, so we went through that in 5 steps. Let's see if we can do another one. Let's see if we can do another one. I'm actually going to erase all of this really quickly. And I'm going to put another problem up here. I'm going to leave my steps over here, and I got a new problem. This new problem has fractions in it. So step 1, clear the equation of parentheses. There are no parentheses. So you don't have to worry about that step. There's no parentheses. But you do have fractions. And you get rid of fractions by multiplying by the LCD. The LCD, if you look at all the fractions that you have up there, the LCD is going to be 10. It's going to be 10 because it's always the largest number or something bigger, right? So 10 is going to be your LCD. Now you multiply each one of your terms by 10. 4 over 5 times 10 is going to give you 8. So that first term is going to turn into 8y. Then you have negative 1 times 10. That's negative 10. Equals 9 over 10 times 10, that's going to give you 9. And then you have 1/2 times 10. 1/2 times 10 is going to give you 5. All of these fractions, if you don't understand how to do these fractions, throw them into your graphing calculator. It'll tell you what the answer is going to be. Now I need to combine like terms on each side. Already have that. They're already combined on each side. So the terms are combined on each side. Now I need to isolate my variable term. I have 2 variable terms, the 8y and 9y. I need to get them together. So I subtract 8y since I'm jumping over the equal sign. That's going to give me 1y, or just y. And now I need to subtract the 5 because I need the variable term to be by itself. So I subtract the 5 and I end up getting negative 15 is equal to y. In this case, I didn't have to isolate the variable because it's already isolated. So I didn't have to do that last step. So I get y is equal to negative 15. Let's try another one. Erase, erase. Erase, 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 erase. Let's try one more. Maybe a couple more. Let's try one more. At least one more. So let's look at this equation here. All right. So first step, clear the equation of parentheses. So that means I have to distribute. In this case, I'm distributing a fraction, but still I need to get rid of the parentheses. So 1 over 5 times 5, it gives you 1. And then everything else stays the same. Now I need to clear the equation of fractions. I need to figure out what my LCD is going to be. In this case, if you look at all the fractions, the highest number is 10, and that's going to be your LCD because 5 goes into 10. So I'm going to multiply everything by the LCD of 10 and see what I get. So this first term, 1 over 5 times 10. If I do 1 over 5 times 10, that's going to give me 2. If I do negative 1 times 10, that gives me negative 10. If I do 3 over 5 times 10, that gives me 6. So that's 6x. And then I do 1 over 10 times 10, that gives me 1, or I can just put x. And then 1 times 10 is 10. So now I'm at step number 3. I need to combine like terms on each side. If you look over here, I can combine these together, the 6x plus 6x plus x, and that's going to give you 7. Now I need to isolate the variable term, so I need to bring my variable terms together. So I subtract 2x, that gives you 5x. So you end up getting 5x plus 10 on that right-hand side, and you just have negative 10 on the left-hand side. But I still need to isolate my variable term, so that 10 needs to be subtracted to the other side. And now I have negative 20 is equal to 5x. I have my variable term isolated, and now I need to isolate the variable, which tells me I need to divide. So divide by 5, and you get negative 4 is equal to x. So we have our answer. X is equal to negative 4. And these steps, I mean, they're not the absolute only way that you can solve an equation, but this is just a suggestion of how I would approach solving a linear equation. See you for part 2. Okay, math people, we've made it to the end of the video with Dr. Simmons. Until next time, I'll see you in the next video.